Well, hi, good morning, and thank you so much for joining me in my shop here on November 17th. Another rainy day here, gray, rainy day. Why so many? So, I'm at the point now where there doesn't seem to be anything particularly wrong with the radio, so I think it's time to turn attention to the alignment and check to see if the two things really: the sensitivity of the radio across the different bands. I need to check that, and the accuracy of the alignment as best I can, and then it may proceed with some alignment activities. Now this particular radio, it's so dark in here. There we go. It's a little better. A lot of radios, to do the alignment, you have to get at the underneath, including this one, because I can see the IF has slugs, so there's a screw adjustment here. And there'll be another one. Oh my gosh, it's buried up in here. How is it even accessible? You know what, there's actually a spot. You can actually get a tool just down through past everything. Very good. So we're going to check the IF alignment, and then we're going to check the sensitivity of the different bands as best I can anyway, and make a judgment about what kind of work is required, what kind of alignment effort is required here. So I'm going to get things set up for that. One of the first things you have to do with a radio receiver of this type is arrange a way to examine the chart that's on the back of this big wheel here. So it's hard to see, but what I've done is I've also arranged this. This is just a twist tie fitted in here with a pointer. You don't know what it's pointing at yet, but I'm going to show you as soon as I explain this a little bit. You can see the camera sitting here. I fixed this camera in place looking at the back of this big wheel. So we're going to look through that camera now and see what we can see back there. How well have I done here? Okay, so you can see the twist tie pointer, the white pointer, and you can see the chart here, which changes when I tune the radio. By the way, the camera is on its side right now, so to get this kind of image, the radio's on its side. I am not. I am actually standing normal, even though I look like I'm the one who's on the side. So we need that pointer to point at the 0 mark, assuming, and it's a good assumption, that the rotor plate here at the front, the big wheel, is mounted onto the capacitor shaft correctly. So I have the capacitor completely open to get to the 0 point. Now I have to adjust that pointer so it points at the 0. Oops. And we're going to want the pointer to be fairly solid too. There we are. Okay, so that's going to mark the value, because you see there's no dial face to look at when you're doing this with this radio. So this is how they've done it. They have a chart on the back, and then they refer to these numbers as you do the alignment work. So let's go all the way to the other end, make sure everything is stable. Uh-oh, I hear a cat. And that's where it ends. These numbers, I don't think they mean anything. I don't think they're degrees. Maybe they are. I don't think they are, though. Right back to the 0. Perfect. That's what I wanted to see. Okay, that's step 1. Now I got to go deal with my kitty cats who are upset. Okay, so here's the alignment chart and the alignment procedure. I'm not going to read through it just now, but I will just point out this last statement down here. Note, all final spread band adjustments should be made with the chassis fastened in the cabinet and the pointer accurately aligned to the dial. So what they're admitting to here is that, try as they may, it's just about impossible to get the alignment to match the dial face, the glass that's left in the cabinet, without putting the radio back in the cabinet. So to some degree, what I'm going to be doing here is kind of a rough alignment. Even though it will look very precise, it'll be based on these angle numbers here, 147 degrees, 19 degrees. Those are the numbers that are on that tag on the back of the big wheel. Looks pretty precise, but I know from experience that in the end, once the radio's back in the cabinet, it probably won't line up all that well. Won't line up exactly with the glass, even if I have it lined up perfectly on this. So, okay, what we want to do today is simply check the radio. So far, anyway, today, maybe this is all I'll get done today. Check the radio's operation on these different bands and see how close it is, and these different frequencies and the different degrees here, and just get a feel for the situation. We'll also find out if the radio is sensitive on each band, or if there's some more problems I haven't discovered until I'm about to discover them now. That's kind of how we'll do this. Okay, it's not too often I appear on camera, but here I am, kind of sideways down here. So, let's get the radio operating. I have to get the signal generator going, radio going, to get everything going here. I already have the signal generator connected to the radio. There we go. Band we are on, I believe, is the broadcast band. Oh, we gotta get this going. We have to get that going. That being my signal generator. Okay, we'll make sure the radio's operating here. Sounds good. And we're right at the bottom of the dial. This would be 530, would it be? 530 kilohertz? Well, let's find out. Right through the IF frequency. That's a little bit surprising. Let's try more power. Okay, see some. The IF in this radio, I'm sure, is 455. What's it doing up here? So that's an indication right away that the IF is not aligned properly. Huh. Now, it's supposed to be 530, it's 842. Probably there's some harmonic thing happening here. Hard to explain that. Wait a minute. Wait a minute, I think I'm at the high end of the band. I don't think I'm at the low end here. Okay, let's keep going. We're going to get to 9, so we're going to lift up here and come down. So this would be 17 or 16. Well, pretty weak response. That's probably really what the radio is tuned to. Put the capacitor open. So 0 is the top of the band. I thought it was the bottom. Well, we should be able to figure that out by just looking at that chart a little bit closer. Let's just zoom in on it here. Just have to look at... Yeah, 147 is 600. The other end, 19 degrees, is 1500. So at 0, although it doesn't write it here, it's going to be the very top of the band. The signal generator signal strength is fairly high. The radio should be doing much better, I think, than it is. How come? I still have it on reduced voltage here. It's only 85 volts input power. Okay, let's crank it right up. You notice it got louder, but the frequency of tuning hasn't really changed. The main thing that got louder was this. Well, that's not a good start. Something wrong with the antenna connection. How do you like that? The ground wire fell off. Okay. Okay, let's try that. The situation got worse. This is a very strong signal being sent to the radio now. Every radio should be screamingly loud with this kind of level. This one certainly isn't. Also, all the noise and hiss should be gone. I seem to get inconsistent results with this radio. On one hand, it seems to work well at times, and other times I get this. Is it because of why? So that would be trying to play a record. It's got to be broadcast. You can tell I got the volume very high from the volume of the click. Well, all we can do is continue on here a little bit. So, yeah, continue on a little bit. We'll just go to another band and try that. But this is not good performance here. I wonder if we should open the link. Let's experiment. That actually sounds better. That's a little hard to explain right there. We'll open the link here. Holy smokes. We have our options now of putting the ground on the ground, or ground on here. It's not the way it's supposed to work, I don't think. Let me check this ground screw and see where it's really going. Does not appear to go to the chassis. Wait a minute. Oh yes, it does. Okay, just as it... I'd be surprised if it didn't. Okay, so the ground screw goes straight to the chassis. This center screw is going to one end of the antenna transformer, and the other end is here. Just... So I'm drawing a conclusion that there's a problem, so I'm very hesitant about reaching that particular conclusion. Okay, let's go on to the next band. The next band, we should see it on the chart here. We should find, well, that's interesting, 1519 degrees. Let's just do that. Let's do that before we move on. 19 degrees. It actually says 19.5. Really? That precise? 19.5. And that's supposed to be 1500. No. It's closer to 16. So at the very least, we can certainly say the alignment's off on the local oscillator. Okay. Okay, next band. Next band up is probably the 9 megahertz band. We're up near the top of it. Well, we don't dial in. Let's dial in where it says. It says 28. Well, I'm not sure what band I'm on yet. Boy, I'm not sure. Let's find out what band am I on. So we click just once. You would think, you know what, you can think all you like. In the end, you got to really figure it out. Okay. I don't want to fish all over the spectrum for it. We're going to guess 9. I'm using order here. I don't know. Okay. Let's do something. Be the top of the 9 spread band, so it's going to be 9.8 or something, if it is. I hear nothing. Okay, so I don't think it's that band. Next one would be 17. Here, let's try 11.8. Well, I went past that, didn't I? So it looks like we're in that top band. Really? Come on, signal generator. Uh-oh. What just happened? That's where signal generator doesn't want to work at this frequency here. Uh-oh. Uh-oh. Oh, no wonder. Okay, no problem. Ooh, anybody hear that? Okay, Jim, what are you doing? I'm just having a crazy time here. Sorry about that. Should have had the camera over this way. Okay, looks like 17 is going to be the guy. Let's turn this down. How does that fit in? 19. So I'm going to have to get the cabinet here. The glass. I got to get the glass. What did I do with the glass? I know what I did with the glass. I will bring the glass here. Good. Just having the glass here is going to be helpful too. Glass. With the pointer. Pointer's still here. Okay, so we're up near the top of the band here. So 18, 19, 20. So there we are, 19. So this is, so the first click is this top C band, which covers basically the entire shortwave band from way down low to way up high. And then we have two spread bands for precision tuning. So we'll go to the next band. Well, first of all, what about the sensitivity here? It seems to be pretty good. Okay, so a good shortwave radio is going to receive this. Nothing. Every shortwave receiver should receive this. So it's taking quite a strong signal to show up at all. It's another indication of weakness in this radio. I think that's how I would assess that. Putting it on a real antenna and really trying to tune in stations is really the best way, but for now that's what it looks like. Okay, we'll go to the next band. Presumably the next band could be the 11 or the 9, so I'm going to guess it's the 9, and we're up here, so we're on 9.7. So there we are. So that's pretty close. But it's a spread band, so pretty close isn't really anywhere near good enough. We are really at the top. Where are we? Oh, I can, wait a minute. Use the chart, Jim. Use the chart. So we know we're on 9. So we could go to 103, and the frequency should be 9550. 103 degrees. Okay, 103. Oops, what am I doing? Not paying attention. 103. That is supposed to be 9550. Let's turn it up. So, pretty close. Pretty close. Now, so at 9550, which is right here, instead we're getting 9544. 95. Oh, it would just be a little over here, almost like you see where the pointer is. So it's not much out. No, wait a minute. Yeah, 5, 4. Yeah, it'd be something like this. Instead of tuning it here, we'd be tuning it here. It's close, very close. Okay, last band. It's not the last band. What? Well, what stupid thing have I done now? So what the heck is going on here? I'm just turning this dial wrong. I think that's all that's happening. Okay, so we're on the 9 band. We're gonna go to the last band. Got to be 11. Got to be this 11. So we're up around 11.9. So, you know, sounds like it's coming in good, but I've got the signal generator set to very, very strong. It's very strong signal. So, this radio's weak on every band. It's possible it's an alignment issue. It's possible it's because the IF is badly aligned. So let's take a look at the situation with the IF here. So we will do this on any band. We'll set this down to the IF frequency. Now I saw on the chart it is 455. We're pounding this into the antenna, but it should leak through the IF. We should hear it. Don't hear anything. Pretty strong signal. The IF is way off. Instead of 455, oh son of a gun, instead of 455, it's 475. So it's quite a ways off, and it's probably not aligned up, you know, all the transformers on that frequency. Okay, so what has happened here? So the radio is showing up weak on every band. Yet I've been able to tune around a bit here and there with it, but not very successful, come to think of it. So maybe it's just a weak IF. It's just poorly tuned IF, and that's really what you know. That's what I should try to do today. So I'm going to take a little break, and then we're going to come back, and I'm going to fix up the IF, and we'll see if that doesn't sort things out. Okay, I think we're ready to start. The objective is to get the 4 adjustments aligned at 455 kilohertz. So what we're going to do is we're going to tune this in the direction I want to go. I'm going to turn up the radio volume here. And we're going to... I can just barely hear it. Let's make that go stronger. And keep an eye on this AVC meter. So this is showing the voltage developed at the detector, and it should go up and up and up as I do this. Okay, up you go. This is just one of 4 adjustments. Doggone it. Get in there. Okay. Okay, so we're just moving it to 466 first off. That's one. Now the other one is down here. Oh, what's with it? Uh-oh. I just ruined my tool. I gotta put a screwdriver in there. Jeepers, I think this is way too big. It's also too much metal. It's retuning the radio too much. Let me try another approach here. Let's try this one. Nope, that can't work. Uh-oh. How am I going to loosen that guy up? Okay, this one will work. Again, I might turn the blade in the end here if it's too stiff. Oh no, it's turning just fine. What was with it the other time? Okay, so now we'll crank this up. Okay, that's 2 of 4. I want to try to get to the top here. Okay, up higher. Let me turn down the signal generator. Okay, that one's... So everything's tuned up to 466 here. Oh. said, oh, because it looks like this is broken on the top here. Can't use my other camera, it's busy. And I can't see with my own eyes. Put these on. Yeah, the what's happened is, you know, this basically the top is a shaft, a threaded shaft, and on the very top, it's as if they've taken a saw and cut, you know, a slot for a screwdriver to go in. And what's happened is one side is broken right off, so it's consequently you can't sink a screwdriver into it. Sometimes you can turn these by hand. Sometimes. No, I can't turn it. Could be it's just stuck a little bit once we get it turning. Let's try with this. Hard to tell if I'm turning anything. Wow. Okay, I wasn't expecting this little problem. Let's try again. See if we can't get enough engagement on the top. Sometimes even the broken, you can still turn them. No, it's not going to grip. It's just no grip happening here. What an awkward situation. Let's get this light out of here. Get in there. Can't really get it out of here. Okay, so maybe I can grab the very end of it. A pair of pliers. Nope. Just put my fingers through the speaker there. Pliers with better teeth. Ooh, what was that? Ooh, what's that sound? Okay, I'm watching the meter at the same time here. It's going up. Okay, so I think maybe it was stuck. Maybe I unstuck it now. No, I still can't turn it. Maybe I can turn it with the tool now. Okay, good. Okay, go up. Meter, go up. I kind of turned a bit. No, it's not going to grip. Meter going up. Ow! Put my finger through the speaker. Not going up. Going down. Okay, so now we got to 466, now we're gonna go to 455 here. Okay, a little more juice so we can hear it. It's too much. Okay, you can see see on the meter now. Signal's way down. Here we go again. Let's use this one here. Start down here. So there is a preferred order to doing these things, but ultimately it doesn't matter that much. Okay, this time we want to stop right at the max. Right there. We'll do the next one. I think the alignment instructions are written on the basis that the radio is so far out of alignment. Yikes. But generally they aren't. They're close when you get them in your shop like this. Okay. So some of the recommended procedures are not really necessary. Feeding the signal into the IF tube grid and doing the second transformer. This isn't the broken one, is it? No. There we go. Okay, watch the meter. Turn down the signal generator. On the peak right there, and now the last one. A tough one. Not moving much now. That's the peak. Right there. Okay, now we double check. Sweeping it a bit. Good. I think it passes the test. Now, did this boost up the radio? Good question. So we'll pick the broadcast band. We'll use that as the standard. That's the broadcast band there, full of noise. And we don't know where we're tuned, somewhere on the broadcast band. Let's go find it here. It's below 9. Let me tune the radio to that. What's going on here? So this should be around 9 now. Do I still not know what band is what? Apparently I don't know what I'm doing yet with the radio. So now I think I have it on the broadcast band. The radio, I believe, is tuned down near down here. That's going through the IF. Sooner or later I'll figure out what band I'm on. Oh my god. How can this be? So that I think is phono. No tuning effect. So I think the next broadcast. Look at the station. So we're on the broadcast band, no doubt about it. Somewhere around where the signal generator is tuned. Oh, finally. I don't know, that took a while. Get signal down. And what we're doing is we're checking sensitivity on the radio. So, how far down can I turn this control? Still hear the signal. The radio sensitivity has gone way up. Okay, let's give it a quick what? We'll check one more band. Okay, so one turn. Now we're on the C band. We're at the low end of the C band. The low end of the C band's around 7 megahertz or something like that. So I think, let's find it. Chart up. Did I say 7? Turn down. So once again, the sensitivity is showing up much higher. Much better. So this is the way it kind of works with this. A really good radio, you're going to hear the signal on that setting. I'm tuning the radio here. And the answer is no, I can't pick it up at all. Okay. There it is. Okay. I think we're done. Whoops, wrong way. I think we're done for today. Okay, so lack of sensitivity, probably due to the IF being way out. How did the IF get that far out? Could be somebody trying to tune it without instruments. Something like that could have gone on. Or just over all the years, it's just drifted out. That was quite a bit out though. Suspiciously, they all seem to be tuned to the same wrong frequency. So I think somebody may have tuned it without instruments at some point. There we go. Okay, so tomorrow we'll do the RF alignment and try to really bring up the sensitivity of the radio. Maybe we're done. Fantastic. Okay, well thanks a lot for watching and have a great day.